Here's something surprising. The Earth has never once, in over 4 billion years, stopped turning. Not slowed to a halt, not paused, not even hesitated. And yet, the question of what would happen if it did has fascinated scientists for generations. Because the answer reveals just how much of our world depends on a motion we never feel and almost never think about. Right now, you are moving. If you live near the equator, you're spinning through space at roughly 1,600 kilometers per hour, faster than a jet plane, and you don't feel a thing. That's the strange part. Motion this extreme is invisible to us because everything around us, the air, the oceans, the ground beneath your feet, moves with you at the exact same speed. It's only when that motion stops that the illusion breaks. Imagine it happening gradually, over the course of a single day. The first thing to betray the change wouldn't be the ground, it would be the sky. The atmosphere itself, still carrying that same immense velocity, would keep moving even as the solid earth beneath it slowed down. Winds would begin to howl at speeds far beyond any hurricane ever recorded, scouring across continents, flattening forests, tearing structures from their foundations. Not because a storm had arrived, but because the sky was trying to catch up with a planet that had left it behind. The oceans would tell a similar story. Water, unlike rock, doesn't hold its shape. For millions of years, the Earth's spin has piled ocean water into a subtle bulge around the equator. Stop the spin, and that water no longer has a reason to stay there. It would begin an immense migration toward the poles, a redistribution on a scale that dwarfs any tsunami in recorded history. Coastal cities as we know them would cease to exist, not gradually, but in a matter of days. And this is where the science gets genuinely uncertain. Researchers don't agree on exactly how catastrophic this migration would be, because it depends on how the slowdown occurred. A sudden stop is effectively impossible according to the laws of physics, since the momentum involved is almost incomprehensibly large. But even a slowdown over months or years would still unleash forces the modern world has never had to withstand. Then comes something even stranger. Without rotation, a day and a night would no longer last 24 hours. They would last 6 months each. One side of the planet would face the sun in a single, unbroken season of blistering heat, while the other side would descend into 6 months of darkness and cold severe enough to freeze water solid across entire continents. The temperate zones we associate with spring and autumn would vanish, replaced by extremes most life on Earth has never had to evolve for. Here's something most people never consider. The spin of the Earth isn't just about day and night, it's the reason we have a magnetic field at all. Deep beneath our feet, molten iron churns and swirls because the planet rotates, generating the invisible shield that protects us from solar radiation. Slow that rotation, and scientists believe that shield would begin to weaken. Without it, the same sun that warms us would expose the surface to far more radiation than life has adapted to handle. So why doesn't this happen? Why has the Earth kept spinning, uninterrupted, since it first formed from a swirling disk of dust and debris billions of years ago? The answer lies in a law as old as motion itself. An object in motion tends to stay in motion, and in the near vacuum of space, there's almost nothing to slow a planet down. Even the moon's gravity, which does exert a very slight braking effect, is stretching our days by mere milliseconds every century, a change so slow it would take millions of years to become the length of even one extra minute. Which leaves us with a strange kind of comfort. The very forces we can't see or feel, spin, momentum, magnetism, are the same forces holding our entire world together. We build cities, fall in love, forget our keys, and argue about nothing, all while hurtling through space faster than sound, completely unaware. Maybe that's the real discovery hiding inside this question. Stability isn't the absence of motion. Sometimes it's the result of it.